Day 16, example problem 2, we're going to be looking at inelastic collisions instead of explosions, and we're going to look at two-dimensional conservation of momentum instead of one-dimensional this time. So in this question, we have an apple that is sitting on a tree, and this is an awful apple, and I apologize for that. Try to fix it up a little bit. Got a little piece and a little stem. We've got our apple. And that apple is going to drop from the tree and is starting at a velocity. The apple at time 0 is 0 meters per second. So it's not moving until it drops. And then after, it's going to drop for a ways, and it's going to start by dropping a total of 5 meters. At which point, that is even worse somehow. At which point the apple is going to be hit by an arrow. So we have time 0, we're going to call this time 1 right before it's hit, and right before the arrow hits it, that arrow is moving, it's coming in and hitting it. And that arrow is moving perfectly horizontally with a velocity at right before it hits it of, 67 meters per second. And that is also at time 1. And then like a frame later, we have our apple. And that apple I normally like my apple drawings. I just can't do it on the board here. That apple has an arrow through it, and that arrow makes it partway through and is just going to lodge in there. And we have our apple plus our arrow at time 2. And that apple and arrow is not going to fall directly straight. It's now going to follow some other path down to the ground. And it is going to travel another 5 meters down until it hits the ground. And that we'll call hitting the ground time 3. So I am asked for where they land. That's the only thing I'm asked for. So I'm asked for this delta x, which we can call position at 3 compared to initial position. How far left did it go after being hit by the apple, after being hit by the arrow? And other pieces that I have, I am told that this apple has a mass of 0.2 kilograms. And I'm told this arrow, oh, of course, they're both A's. Oh, I called the arrow, the apple I said is lowercase p, and the arrow is lowercase r. I went with the second letter in my solution. So the mass of the arrow is a tenth of that, 0.02 kilograms. And where will they land? Oofta. So we have time 0, that is off the board. I will add the 0 over here for clarity. Time 0, time 1, time 2, and time 3. And we want to figure out down at time 3. However, as you may have guessed, we need to know what happens from all the way down. So we're going to have to start at time 0 and make our way all the way to time 3 in order to find, put it down here, what to find. I'll put delta x. How far to the left is it when it hits the ground? Where am I going to find this final apple/arrow combination? Okay, so let's start by going from time 0 to 1. Between time 0 and 1. In this case, we're only looking at the apple. And I know that my velocity of the apple at 0 is 0. My position of the apple. Okay. Do I want to do this? So instinctually, I want to call that positive and that positive. But I have a feeling that people are going to dislike that. So we're going to instead call our normal upwards positive and to the right positive. So positive y, positive x. So we follow our normal sign conventions there. So my initial position, let's say that this is y equals 10. This will be y equals 5, and this will be y equals 0. So this is 10 meters up, 5 meters up, 0 meters up. So we have, between 0 and 1, we have y at 0 is equal to 10. Y at 1 is equal to 5. Both of these are in meters. And I have my acceleration between 0 and 1 is just completely in the y is just gravity, which is going to be negative 9.81 meters per second squared. It's acting down, hence the negative direction. That's gravity. Do I have anything else that I need to be throwing up there? I have my mass of my apple is 0.2 kilograms. Okay, those are the pieces that are relevant to time 0 to 1 for the apple. So what I'm going to do is, looking at them, I would like to know, I want to know in this case, it's not my overall what to find, but in order to move to my next step, I want to find my velocity in the y technically at time 1. How fast is my apple going at the time when it gets hit? Because this guy is going to be my collision. So in order to do that collision, I need a velocity. And we could try to solve it back up and realize everything we're missing. I like that method, but I don't have the board space for that method here. So we're going to work our way down. So velocity, what I'm going to do is I want the velocity. So the easy way to do this, because I don't care about that time, is going to be using my this kinematic equation. So velocity at 1 squared, this is in the y, is going to be velocity 0 squared, again in the y, plus 2 times my acceleration in the y, times y1 minus y0. And my velocity 0 in the y of the apple is 0. So velocity 1 in the y is going to be the square root, because that's what I want, velocity 1 for the y, square root of 2 times negative 9.81 meters per second squared times my y1, and my y1 is up here as 5 meters, minus my y0, which is up here as 10 meters, which is good because that ends up being negative, which means that negative times negative will be positive. So I can actually take the square root of it, that means, which is wonderful, having a solvable problem. And this gives me velocity 1 in the y is plus or minus, because we've got a square root there. It could be positive or negative 9.90 meters per second. Well, I'm going down, And I said up is positive, so it better end up being a negative number. So there we are with that guy. So that is velocity 1 in the y. That was what we wanted from time 0 to 1 so that we can solve time 1 to 2. And that guy is complete. A note to you guys, I could also do this. I have an extra way. In fact, let's go ahead and do it. I'm going to say that I have between 0 and 1, I can look at my potential energy at 0 plus my kinetic energy at 0 plus my potential energy of springs at 0 plus my work done is going to be equal to my potential energy at 1 plus my potential energy springs at 1 plus my kinetic energy at 1. I've got no work that's being talked about between these things. My kinetic energy is going to be 0 at time 0 because I've got no movement. I have no springs at all in this problem, so I probably didn't even need to write that down. So kinetic energy is potential energy 0 minus potential energy 1. So potential energy 0 minus potential energy 1, which is going to be mgh. So mass, I'm going to write out the numbers. No, we're going to write it out with letters. We'll do mass times gravity times height of 0 minus height of 1. Height of 0 is 10, height of 1 is 5, is going to be equal to kinetic energy, which is 1/2 mv squared. In this case, my masses cancel. That's why I left it like that. So I have the square root of 2 times 9.81 times h0 minus h1, which is 10 minus 5, is going to be equal to my velocity at 1. Well, that is the same equation that I have right there. It's going to give me the same answer. So it's going to give me velocity 1 in the y is equal to 9.90 meters per second. And energy doesn't matter what direction it is. So in this case, we just have to fill in. We know that there's a negative sign there because we know it should be acting down. So that is our other way of solving this. A final way of solving this is I could go through and I could solve for the time it takes to get from one to the other and use that time to figure out the velocity. That seems like overkill. That would be the y1 is equal to y0 plus velocity 0 times time plus 1/2 at squared. This guy cancels out because he's 0. It ends up being the same equation. You just solve for time, and that's some number, and then we can say velocity at 1 is equal to velocity at 0 plus acceleration times that time. I have the time, I have the acceleration. I end up with the same number. So 3 ways to do the same thing. We can use any of them, and we will get there. But we know that velocity of the apple at time 1 in the y is negative 9.90 meters per second. And I'll go ahead and erase all of this because board space. It looks like I'm shaking, but it's the whole table and camera setup that's shaking, so I erase this. Okay. Next, let's look at between time 1 and time 2. What's happening between 1 and 2? We assume that we've got next to no movement. We just have 2 things that are hitting and connecting to each other. So I have velocity of the apple in the x at time 1 is 0. Velocity of the apple in the y at time 1 is going to be equal to negative 9.90 meters per second. My mass of my apple is going to be 0.2 kilograms. My velocity of my arrow in the x at 1 is a negative 67 meters per second. My velocity of my arrow in the y at 1 is going to be equal to 0. And my mass of my arrow is 0.02 kilograms. In this case, this is where my collision takes place. So I'm, again, going to use my conservation momentum, and I'm going to say that my sum of my momentums in is my sum of my momentums out, except in this case, I'm going to have to do it for the x and the y, because I've got both of them going on. So we'll go ahead and add my cross line there. Let that marker rest and see if this guy's still clean. I've got my x and I've got my y. So going in, I have my mass of my arrow times my velocity of my arrow in the x at 1 plus my mass of my apple times the velocity of my apple at 1 in the x is going to be equal to the mass of my arrow plus the mass of my apple times the velocity of the velocity total. So I'm just going to call it the velocity 2 in the x. Almost fit that in one row. Let's see if I can do it for this one. And then the same thing, mass of the arrow times velocity of the arrow in the y at 1 plus mass of the apple times velocity of the apple in the y at 1 is going to be equal to the mass of my arrow plus the mass of my apple times the, still fitting, okay, times the velocity 2 in the y. And that's going to give me what my initial movement is for that second part of the problem. Mass of my arrow times, well, velocity of my arrow in the x is something, so I will put this down. So I have mass of my arrow is 0.02 kilograms. My velocity of my arrow is 67 meters per second. My velocity of my apple in the x is 0, so I don't have to worry about that. And that is going to be equal to the mass of my arrow plus the mass of my apple, so 0.02 kilograms plus 0.2 kilograms times the velocity of 2 in the x. And then finally, I'm going to take this 0.02 times 67 and divide by this 0.22, and that'll give me my velocity 2 in the x. And that gives me a velocity of 6.09 meters per second in the x. That is correct. Okay. And then my second piece here, I am going to have my arrow, in this case, is not moving at all in the y. My apple is, so I've got my mass of my apple, 0.2 kilograms, times the velocity of my apple in the y, which is, oh, sorry, this guy's going negative 67, which means this is going to be negative. This guy is going to be negative 9.90 meters per second. And that is going to be equal to my mass of my apple plus my mass of my arrow, so 0.02 kilograms plus 0.2 kilograms times my velocity at 2 in the y of my total thing. And when I solve for that, I get velocity 2 in the y is going to be equal to negative 9.00 meters per second. Those are the velocities of my total piece at time 2. So I can add a little bit of a note to this point and say that my velocity 2 in the x is equal to negative 6. That's not a 6. Negative 6.09 meters per second. My velocity 2 in the y is going to be negative 9.00 meters per second. And I can tell you my mass total is 0.02 plus 0.2 is going to be 0.22 kilograms. And I write all that down so that I can erase everything that I have here on the board. And I can start moving towards that final answer that I'm after. I might switch color just to give these white ones a rest because they somewhat revive themselves over time. So, okay, perfect. Let's try doing this last step in yellow. Okay, so I have my time from 2 to 3. And for time from 2 to 3, I have velocity of 2 in the x is negative 6.09 meters per second. I have my velocity of 2 in the y of negative 9.00 meters per second. I have my acceleration in the x is 0 because we don't have any forces. And my acceleration in the y, I just have gravity, so it's going to be negative 9.81 meters per second squared. And I want x3. I have my mass. I wrote that down, but I don't actually need it for this. So 0.22 kilograms. But there's all of my information. And I can go ahead and get started on this. This is not a momentum question. It's not a collision. There's no impulse. It's just a kinematic equation question. In this case, we could say that we have my initial apple. That is, again, not an apple. I think these pens slide differently than I want them to. And if I look at my forces on it, I have mg downwards, and that's just saying sum of my forces in the y is equal to mass times acceleration in the y. I've got mg is equal to ma. This is negative because it's acting down. Masses cancel. Acceleration is negative acceleration of gravity. Done. At this point, we have accelerations, we have velocities, so we're just jumping straight to our kinematic equations. With what I am trying to solve, I want x. I don't have time. The best way to do this is I need the time for it to hit the ground in the y. So I want the distance it travels in the x. And what I do know, I am missing one thing, and that is I know y at time 3 is going to be equal to 0. It has hit the ground at that, and y at time 2 is going to be equal to 5 meters. And technically, x at time 2, we know, is 0 meters. So that's what we have. So with this, if I want to solve for time, the obvious one is going to be my y3 is going to be equal to y2 plus velocity 2 times time minus, plus 1/2 acceleration in the y, so this is velocity 2 in the y, times time squared. And what's going to happen here is you're going to get a value, y3 is 0. 0 is going to be equal to 5 minus 9 times time plus 1/2 times negative 9.81 times time squared. And I need to solve the quadratic formula here. If I do solve it, I get a time of either 2.28 seconds or negative 0.45 seconds. Of those, it should hopefully be fairly clear that this is the number we want. I told you that you guys are never going to have to use quadratic formula in this class, so we can solve this without getting into quadratic formula. So what we can do is, in order to get there, we can try to find the velocity as it hits the ground. So we can say velocity at 3 squared is going to be equal to velocity at 2 squared, both in the y. Technically here, I should have, I can kind of draw it. I can say x, this is everything going on the y. I don't have space to do both the x and the y on the board at the same time here, so I'm only writing y currently. Plus 2 times acceleration in the y times my y at 3 minus y at 2. And that comes out to velocity 3 in the y squared is going to be velocity 2 in the y, negative 9 meters per second. If I square that, plus 2 times my acceleration in the y, which is negative 9.81 meters per second squared, times my y3 minus y2. y3 is 0. My y2 is 5. And that, I take the square root of that. Velocity 3 in the y is going to end up being, sorry, I did use the quadratic formula when I solved this. So we've got 2 times 9.81 times 5. The negatives cancel. That is going to be added to 81, because that's 9 squared. And those both end up positive. And I take the square root of that number. That number is 179.1. And velocity 3 is 13.38 meters per second. And then if I go in and I say velocity 3 in the y is equal to velocity 2 in the y plus my acceleration in the y times my time. So velocity 3 in the y should be, oh, sorry. This guy is negative. It didn't all of a sudden switch to, so that we've got the square root, and the square root, we have to have a negative there. So velocity 2 in the y, velocity 3 in the y is negative 13.38 meters per second. Velocity 2 in the y is negative 9 meters per second. And then acceleration is negative 9.81 meters per second squared times my time. So I take that negative 13.83, I add 9 to it. That gives me negative 4.38. I divide that by negative 9.81. That gives me 0.4 0.4467 seconds. Quick point on this. This number is correct. I went back and I looked immediately when I saw this. My quadratic formula, I had a negative sign missing, and that's why this was not one of those two numbers. So quadratic formula does in fact give you this piece. I apologize for missing that and writing those numbers up before, but the two will end up with the same numbers. So this is our time, and with this time, we can now say that time between 2 and 3 is 0.4467 seconds. And I'm going to go ahead and erase that. And that time is what can move across this line between y and x. So now in this case, I have my x to solve for because I want my final x. So I've got y over here, which I'm already done with. I've got my x. I have my time that I just found between 2 and 3 was 0.4467 seconds. That's what's going to move over here. And my x, I can just say x at 3 is going to be equal to x at 2 plus velocity at 2 in the x times time plus 1/2 a in the x times time squared. My acceleration in the x is 0, we said right up there. My position of x at 2 is 0, we said right up there. So my position at 3, which is what I'm trying to solve for, is going to be my velocity at 2 in the x, which is negative 6.09 meters per second. And that is being multiplied by my time of 0.4467 seconds. And because I had that incorrect answer, I'm going to go ahead and plug that in. So times negative 6.09 is going to give me a value of x3 is going to be negative 2.72 meters. And that is the distance it has traveled left to right. So thanks for bearing with me there. Had a quick blooper on the board, but everything worked out in the end. Hopefully that is helpful for you. Take care.